Okay, I have started this video a few times and then stopped it. And, oh, shit, I can't get it. What I'm trying to do is illustrate how you can understand this cost of a battery together with solar and take out all this mystery of this crap you see on all these slides, that levelized cost of storage, that levelized cost per kW of storage, all this shit. Sorry to say this. This is when we're going to uh, uh, have a system, and we're going to say, let's get this system independent of the grid. Now, I'm only doing this for one day. Let me explain. Yesterday, I heard, oh God, I was listening to something about the pandemic and all that stuff, and they said, I've heard this so many times. I'm so sick of this stupid statement. Oh, all models are wrong. Some models are useful. Okay, blah, blah, blah. But then this lady also said, look, here's what a model can do. Here's what a model, you put some inputs in and you see what the effect of the inputs are on the thing you're concerned about, whether it's how many people are, oh, God damn, uh, how many people are going to die from the virus, and now what's going on here? I don't want to see this thing. Shit. Okay. Uh, how many people are going to die? Whatever. Yeah, that's the model. Okay, they've been talking about models a lot. That's good news. But this horrible saying, could they just stop this damn thing? And then I can't. Oh, man. Let me do an F5 and go to special and go to constants and only take the numbers. Okay, and then go to home and let me color the numbers with hmm, that's not what I want to do. I want to color them over here with some kind of blue. Oh, that's too light blue, isn't it? Oh, that's too dark blue. Shit. Good. This is going to be good enough. Okay. There we go. I'm going to be able to change all of these things and then see what the cost of the battery is. Now, I'm just going to do it, and then I'm going to go back and explain things. So if I have the battery life to be 15 years instead of 12 years, all this crap about, you read this stuff, who knows? Some people say the battery life is going to be 20 years, and then you get a much lower cost. And then, I'm beeping, it seems, and then the battery cost, oh my gosh. We have all of this stuff in that last thing, and I'm going to put this, I'm going to update this and put this on my website, and all I did was try to clip some stuff, and all these people who say the battery cost, some depends on how long this is, 100 per kW in the future. This battery cost, if it's 4 hours, is 378. This battery cost, God knows, if it's 4 hours, it's who knows, 250 maybe. I don't know. This battery cost right now, if it's only 1 hour, it's 477. This one is, it doesn't say how many hours it is, and if it's today and it's a big battery, it can be 385. God knows how many hours it runs and all this. You get all this uncertainty about this. You get uncertainty about the life, the O&M costs, the depth of discharge, and all of that. And maybe, okay, all models are wrong, just some are useful. Shit. Okay, if we make the O&M cost 2, we can see this. And what we're seeing now is what the total cost is. The cost of the solar, which I have a really, really low cost, because what I did is went down here and found, oh, come on, the world's lowest cost, EDF and Jinko Power, and somebody else. They made it for 1.35 cents. They use probably some bifacial, some tracking. Who knows? They don't tell you what they do. And I would strongly suspect that this is a real cost. I suspect that this inflates. So we use this. I'm going to come back to that. Okay, we use that. And I put it in. This is per megawatt hour. That's per kilowatt hour. It would be 1.35 cents. Inflated. It's real. I should put LCOE real. Okay. And then you can try it. Now, you might not agree with everything. You might not even agree with my method of computing LCOE, but at least I'm being transparent. At least I'm goddamn showing it. And then we can put a learning curve if the costs don't go down. If we have to replace our battery after 15 years or 12 years or whatever. And I had another video where I tried to prove that, and maybe nobody give a crap about that one, but we can put in learning costs and see what happens to the overall cost of this thing over time. And then this depth of discharge, I even have that one in. If that's 100%, we can go all the way down. We get a lower cost, but if we have to put a battery in, we have to put a bigger battery in because we can't take it all the way down. And when we measure the kilowatt hours of potential storage, if the potential storage includes a depth of discharge that we can never go down to, well, that increases the cost. So that's a pretty big one. And then we can put the round trip loss in. That round trip loss is the amount you put in compared to the amount you get out. Okay, and you can do all of this. Now, I'm going to show you how to get there. We're going to show you how we we put a load shape in, we put a solar amount in, we put a little balance of the battery in, we put a round trip efficiency in, and we do all of this. Now, if we do this, what we could do is we could say, let's just start with a case where we put in 100 in. Now, I was struggling yesterday like crazy. Well, I can't put in exactly the same. So what? If we do this, let's put a little less in here. For some reason, I'm getting, oh, the load might, let me put a different load shape in too. This one. Oh, that didn't work either. How about, we'll go through this. We've got some extra production here. Let's put a little, not, we'll put a little lower of a solar in. And then because actually this solar, I think we might be getting more capacity out or whatever, then this is all unserved energy. We could do that. That's one strategy. And if it's not unserved, this could come from diesel plant, gas plant, whatever. And then you can, and I'm going to show you in this video how to, and you put more solar capacity in, and then if we put more solar capacity in, eventually we're filling up we're using this extra solar here to fill up the battery. And what you want to do, I suppose, with this horrible lady who said this, oh, model you at least can look at parameters. You can kind of see what you're doing, okay? And then we finally put in just enough battery capacity. So we just get at the end of the day, this going down to zero. Now, somebody right now, rightfully, like somebody told me, rightfully, you might have said, so I'm going to compute the exact amount of capacity to bring me down for one day. Now, you might say, what? How ridiculous is this? That's just one day. What if you do it a different day? Well, we'll do that. We can look at a different day. Let's look at, this is the solar capacity for different years. And let's look at, let's look at a summer month. I think it's really hot in August. Okay, and in that case, for some reason, we have some unserved energy. So we have to put more solar in to meet this load, or less, or something like that. We have to put it in a different time. And I click on the goal seek. We're going to show you how to do that, remember? And you get it here. And in this case, because of the size of the battery you have to put to capture all this and move this over here, okay, you need 2 times as much solar as you did if you were just building the solar for the load. So, or the solar to, I call it the solar to demand ratio, whatever in the heck that means. I made up something. You need 5 hours of storage to meet your kilowatt hour of demand. No. To meet this kilowatt hour for the day, here's the maximum demand you have for the day, the maximum amount you're going to use in 1 hour. And here's the solar capacity you need. This is the kilowatt hours you use over the day. Total load demand. Okay. Now, in I'm going to try something, and I'm not very good at this. I'm going to try to explain how we do this now. And then we're going to go back, and maybe in this video, maybe in a subsequent video, who knows? You know, I don't know how to put that little thing in that when I watch some videos on all this history stuff I watch. They say, go to the next video. Like, here's part 1. Voici hier ist die Teil 1 und dann die Teil 2. I'm trying to watch this stuff, okay? Well, you don't care. And then, so we have this much demand. Now, so I'm going back to this thing. And what I'm trying to say to you, if when I measure the LCOE to get out of this horrible, stupid, god darn confusion about, ooh, LCOE of storage and all that shit. Oh, why don't we do this? Why don't we compute the total energy provided? And I'll call this demand. Demand for a day. How's that? 24 hours. And then we, from both solar and discharge. So you get this, you're meeting the demand. I'm so nervous. You're meeting this whole demand, the integral, what's under the curve, you're meeting from, and this was pain. It took me like an hour to get this stupid graph right. I have trouble with the whatever, the area graphs, adding it up, and then you can't, oh shit. This is the total demand, and this is what we meet from solar, and this is what we meet from batteries. You know what I should do? Maybe I should almost make a, I'm not going to do that. I almost should put a little graph at the bottom of that, shouldn't I? And then we compute the total capital cost. Now, the total capital cost here, I put the capital cost of the battery, but I didn't put the total cost of the solar. Now, I did almost the same thing for solar, okay, where we just have solar alone. How did we come up with our solar cost of 13.5? Okay, now, crap, I realize I did something just horrible. When we put everything together, we need to put in the denominator, okay? So I'm gonna have to fix things, and oh shoot, I make mistakes, right? So you put the total cost in. The denominator is the demand. And maybe it's better like this. So let's say we have a battery cost, a solar cost, solar O&M, battery O&M. You add up all the solar cost, all the battery cost, and you divide it by the total. So this is how it would be if it was simplified a bit. We could put maybe I should, can I put another space here? Why not? We could put the solar cost plus the battery cost divided by the total load, or you could put the solar cost, battery cost, blah, 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 blah. So when you do this, I'm glad I'm kind of catching this now. We have, here's the UAE tracking. Now what we have here is we need we can put in the capacity factor and all of that, but what we really need for the total amount, we need the total amount of load over a day, but then, this is all on a annual basis. So let's put 365 .2, and now I'm gonna stop just for a minute because I did. Okay, I had to stop, but I really didn't mean to. What I I actually did it all fine. We put the cost per kW of the solar in. You press Control and the little, oops, that's wrong. That came from somewhere else. The cost per came from here, the cost of the battery. You put the amount of battery storage after DOD, kWh. Okay. Oops. Oh no, I gotta make this a tiny little bit bigger. Okay. That's how much we need. That gets multiplied by 300. Don't worry about whether solar cost is multiplied by, in this case, 575. In this case, what I had done, by the way, is replicated this UAE thing, okay? And I'm going to come back and show you how I did this, and it's fascinating. Look at this. The loads are just flat, right at our 1000 STC number. Of course, it's a lot hotter, so the temperature isn't at the STC. And look how flat these are, and you can see what the tracking effects are. And that's all through in this file. Go to this file, and it's all through just going to the wonderful little website here and downloading the stuff. Okay, and where's the UAE one? Okay, I went and got it from different places, obviously. Okay, and you plugged in UAE, you see what you get with tracking, you see what you get without tracking. You put it, you get the hourly data, okay, and you can go and check and see if I screwed up, but here's the UAE, and I have a little index function so I can select just that one or somewhere else and test this all out and in a minute demonstrate how this works in other situations. And I put a whole lot of junk in this file. I have to clean it up now probably, but I want to, I got in trouble. Some people really complained about my class, said, oh, you got too technical, all that crap about generic macros. Just tell me the answer, and I don't have to see exactly every goddamn little tiny calculation. Okay, so how did we get this number? And I thought, oh shit, I made a mistake. And I always get worried about that. But, so I have a little thing over here that says, okay, here's the capital cost. And I put a capital cost for a current battery and a replacement battery. Now I just put my learning thing back up to 100%. So the capital cost is the same for both the learning and the first replacement and the second replacement. And I'm repeating myself, but in the other one, I did all that crap. Oh no, somebody's coming. Hope I don't get disturbed today. Can't take it anymore. All right, and this if sometimes there are 365 days in a year, sometimes there are not, because if you don't remember that there's a leap year every fourth year, you're kind of, so I forgot to put in that leap year in here, so that we're spreading the total cost of the I'm getting disturbed. I'm really having a tough time with my concentration right now. We're spreading the total cost of all of this 198, control square bracket to find it. That's how many kilowatt hours we're putting into this whole thing, and then F5 and go back. That's how much we're putting in, and this is the size of the battery we need. And I'm going to show you exactly how to get that with the DOD and all that crap. Okay, this is here, right here. That's the size of the battery. And that's what you multiply this by this, and you get the total capital cost. This is per kilowatt. Okay, that's how we measure the total capital cost. You take the total solar capacity, you multiply it by how much you put in as the cost of the solar capacity, and that's what I put in. And then you get the total capital cost right here. And that you divide that by the total load, not just the load that's during the day or anything else, just the load. Is that difficult? That's here's the total capital cost, excuse me. Here is the total load. And then we put in the O&M cost. I put in the solar, we put 11.5 per kilowatt per year. That's, of course, in real terms, and you're going to have to escalate that. For the battery, I just said 3%. And, of course, you can change that. I'm not going to even go back. And then you're just about finished, because then you go and you say, okay, I have a 35-year solar life. I put no income taxes. You can put all sorts of income taxes and get variable declining balance and all that stuff. And I put a higher degradation, and this degradation I hope comes from here. And I hope this principle of using F5 and going back and forth without all those horrible, stupid blue things. And then we put our capital structure, and I keep the capital structure constant, assuming continual refinancings, which really happens. Not this crap about just a simple project finance model. And then we put an inflation rate, and we get a real carrying charge rate eventually adjusted for degradation. This is our kind of final number. And just a minute. And then we put our total capital in, and then we say, okay, well, if we're going to just compute a nominal bullshit carrying charge, we're not going to do that. Let's compute and then we divide it out, and that's our cost of but dividing it by the total production. That's the cost of the battery and all that in nominal terms. But then I'm going to get the real rate, and this was. If you look at this was I adjusted that 47. I hope it's 47 is. I adjusted that for the income tax rate. So this really should be carrying charge real after tax. This is like the final one. Okay. And you can say, I don't believe you, you're full of crap and all that stuff. So what? It really does work. It really does. And you don't have to ever do it. And then you put your O&M in, and I made another video explaining how you have to adjust the O&M for inflation and all that, and then you get your final numbers. Your final numbers. Oh, I did kind of screw up. Okay, this should have been that one. Okay, not a big. I'm not really worried about that. And then, by the way, you can prove this all with the financial model that I've said umpteen times recently. Okay. So we get all of we get all, it's going to change my numbers a tiny little bit, and we get all of our numbers, okay? And that's the cost. So now we can, now once we have that little, somebody else said, I'm giving you an LCOE calculator, and I'm doing the same thing. It's kind of a little BS. If I put a learning adjustment in, I hope I have it on. Yes, it's we have this, and if I put a 10-year life in, it all goes through that calculator, and it all matches a whatever a financial model, and that's the idea of the LCOE. Should I go back? I don't know. I was thinking about this person who said modelings are all wrong, but God, but some are useful. Oh God, the usefulness. I guess I'm going to use that horrible statement, but the usefulness of the model is that it can kind of give you a starting point here, and tell you if you've got anything close. Okay, and now let's put a different uh, uh, um, let's put a different uh, uh, pattern in. Uh-oh, and now let's try this somewhere where the sun isn't so good. Paris can be sunny. I'm not gonna. Oh, Paris is so nice. I want to go. Ghana was very sunny, but Montreal maybe. Nah, sometimes it's probably not so sunny up there. So look, in this case, and we didn't use tracking, and in this case, actually in August, we had a nice sunny day in August, but let's put a different day in. Uh, God, they're all sunny. Oh, there's a not so sunny day. We had little clouds, sunlight, clouds, and we can go back to another day. Ooh, that was a cloudy kind of day all day. And every time you do this, you get a different amount. Now, that also comes into here. You can see in this thing where you do month by month by month, just how it all works. Now, to get this, it's so damn easy to do. What you need to do is download all that stuff. That's what took so long. Downloading all that hourly stuff. Where is all that hourly stuff? Where is it? Come on, this is the hourly load. Now, I just used a little index and I just used a little, yeah, I'm not going to get technical and show you how I did that. Okay, and then, hello. Okay, and then I just put the, put just pick the Montreal out of all this hour by hour stuff. And if you look there, we've got 105,000 lines in this. That's why this thing is big. And then to put it on the website, I had to take the macros out, which really kind of was upsetting. I don't know why. So we've got our hour by hour stuff. Okay, and excuse me, this is the hour by hour uh, 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 sunlight that hits the plane. It hits the solar panel. Okay, and when we would have that hour by hour sunlight, eventually we're going to have to adjust it by a performance ratio. So down here, do you see these sum ifs? All they do is take a sum if and you use the whole stupid line. And I've got to test this out. This is another thing. I'm so backed up with all this. I've got to prove that using the whole column and all that doesn't slow you down. Maybe it does. If it does, oh shit, I don't want to redo it anyway. But it's so much faster. We just take in this case, we took column L, which was Montreal, and we go through and we get the kind of how much in-plane radiation you get. And remember, that's the kind of our famous 1,000, and we get a 3.4% standard deviation going year to year, and they didn't. Some of them had 2015, and some of them didn't. You can get all this stuff. Just fantastic. I've been told by some really analysts that this was, it's not the most perfect website, perfect data, but it's not all that bad, okay? And then we can put in different, now what I did is I adjusted the performance ratio. There's a performance ratio they have in that thing, but it's really, really low for UAE. I said these are going to be bifacial, these solar panels where you have the reflection on the bottom, and it works if there's sand down there, and I know there's a lot of sand in UAE. So I adjusted the performance ratio up for the bifacial stuff, and then we can have all of our LCOEs for different places. So now I'm finally going back to Montreal, a nice place, ice hockey, everything else. But if we only had this much solar right now, we kind of said, okay, to meet this demand, whatever this demand from Allegheny Power, who cares? It's just a demand curve, and I put all those demand curves in. I'll put this one in. How's that one? So that's a different shape, a little bit less and more. And I really wanted to find some good commercial buildings that I can really look at, and I could put a flat shape in, and I put some commercial buildings in. Let's put this commercial building in. okay? And right now, the red means we have unserved energy. So again, so what we have to do, and the expensive thing we have to do, is to meet that demand, we got to put in a whole bunch more solar power. And all these horrible reports that with the costs and all that say, oh, here they just produce something and don't show you really what you have to do. And my idea was this man I met named Maximiliano. Oh no, I couldn't put more than that in. I gotta. Oh well, I'm gonna leave it. Oh no, I won't. I'll put some extra in. Okay, so to meet our 100 in this crazy case, to meet our 100 load. Oh my God. And this shows you the problem. We can't really do this. Maybe we can in UAE because because we oh God, I might have to put more than 1,000 in. We have to put 10 times as much solar as we have. Ah, there we go. And of course, you could have, instead of doing that, you could have done a goal seek. And that means you got to put so many batteries in, the cost comes up to 12.9 cents. And you might say, that's not even all that much. Okay. It might not be actually. So we got to put a whole bunch of extra solar panels, get so many extra solar panels just to meet our load. Again, okay, if I go back, oops, and I didn't do this right because I forgot to use the where are we? We're in Montreal. Montreal. No, Montreal, no tracking. Aha. And then do I have to, I don't have to redo that, but our solar cost was higher because we have less capacity factor, and now we're up to 14.6 cents. And that's pretty expensive. It's not going to beat a natural gas plant, that's for sure. And you could compare that to all this other kind of capacity where you really have it fixed. So you might be back to the point, and here's where I'm going back. Now I've said this so many times that you might say, no, let's just screw the storage. Let's just take our total levelized cost, real levelized cost, adjusted for inflation, damn it, and compare that to today's gas price. And where's our Montreal? Montreal, no tracking. We could beat it if our cost is this. If we put a higher cost in of solar, maybe we can't beat it. If we need a higher IRR on our solar, and remember that just goes into all of those different factors. And I can see what I'm going to have to do now. I'm going to have to make a second video that's a more technical video. Maybe nobody will watch that one, but for me it would be so much more interesting. All these things that drive and if the gas price is only 3 USD, then we can't beat the gas price with a heat rate that brings the cost of natural gas to whatever 3 times 6.5 divided by 10, whatever, 30, right? 3 times 6.5. 6.5 is a heat rate, the conversion of gas to electricity, plus some variable costs. And I put all of those in. In the LCOE calculator, so we can, here I said, what idiotic thing to say. We can put on our natural gas price here, change that. I'm not going to go through all these gimmicks. I'm not going to get in trouble for going through all the gimmicks. I'm just going to tell you. And there's our heat rate, and there's some variable cost in USD per megawatt hour, and there's our total variable cost. And then you just put in all the costs and all the production. And I'm saying this over and over again because I kind of discovered this. Anything I'm going to make, if you're taking the levelized cost of your house and you you put too many rooms in the house and you want to compute the levelized cost of your house, including all the energy you're going to waste by having these rooms you never even see. And if there's a flood, you don't even notice that they've gone away. I've heard of a story like that. Okay, you don't need all this stuff. You've got operating cost and capital cost. Okay, and then you have to add the furniture. You've got to put in all those other. If you've got 8 bathrooms or whatever, and you think your life is good because of that, whatever. Sorry, don't get mad. All right, so that's that, and I think So I'm putting this on the website. Oh, let's do one more. So if we take exactly these parameters and now we switch it back to, let's put Chile, not the, you know what I mean, the country. And, if you go, oh, shoot, we had a bad thing. I'm going to cheat. I'm going to put UAE back here. And notice, oh, there was a little bit of problem here. Maybe I should go down to 2011. Oh, see, in April, maybe they got a couple of clouds in UAE. But by the time you get to June and July, you don't. Oh, you know what? I started to show this and I didn't finish it to you. Sorry. So if you want to find these different, make these graphs, and for me, this is a really big deal. You just put equal match and you put your date in with your month, year, and your date function, and you match this against, you go and find all of this stupid thing here, this hourly solar, and you match it against the date, and you don't bother with any kind of, there was a little lag there. You don't bother with all the oh, locking it and everything else. You try to find the laziest way to do things. That's a real principle. And then you take that number, and that's the row number. Uh-oh, I have a meeting. Oh no, that's why I got to finish this. This is match to find row number. Okay, and then once we find the row number that's the first hour, the first hour of this one. And if you don't believe me, you can waste your time, which I'm not going to do. Yes, I am. 8:48, 7:30. Okay. And then what day was that? Do you remember what day that was? That was 24th of July. 24th of July. 28th of July was my kid's birthday. 24th of July, 2010. Maybe it's your birthday. You go to the thing, hourly, and you press F5, the trusty old F5. Oh shit, I forgot what it is. Damn it. 48, what was it? I can't remember anymore. That was cheating. 48, 7:30. I'm trying to think about two things at the same time. I'm being yelled at all the time for making videos. 48, 7:30. You go down there, and that is the 7th of July, 2010. And then you take the next rows just down there. And after you take the next rows down there, so you just put a little thing over there, and then you just count this. So you've got to subtract 1, and that's the next row, and the next row, and I just did 20 rows. And then all you do is, in that index, you just put an equal sign, and you put an index and take the whole stupid row, the whole column rather, and then point to this row with the index. That stupid little trick, and then you do it for, in this case, it was up here. We put 1 day, and 1 day, and then over here we put 1 week, and then over here I went all the way down because a week always has 168 days. That's 7 times 24 probably, and then 1 month. Well, you can take, the months have different days. That's the painful thing about months. Why didn't they put the same? But you can take, what, 8,760 divided by 12, and say a month on average has that many it has 730 days. Okay, that's what I did, and that's what I show here. And then you just make a graph of this thing, and blah 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 blah. And then I had one little drop down for the tracking and one for the other. Okay, so that's the summary of it, and I'm going backwards, and so then I put UAE tracking, and we put the kind of cost of UAE tracking up here. Okay, and then, oh, it's 5:30, don't worry about that. And then we say, okay, we go down and we do our goal seek, and we see that one, we need less batteries, and it's still giving us 9 US cents because the battery cost is so much higher than this. And I guess, I have to put in a longer battery life, and have to put in a lower battery cost, and I have to put in a lower replacement cost, and a depth of just discharge of 85%, and on and on and on, and then I get 67, which really, it's not so bad, but not so good either. But it gives you the real answer. It gives you the real answer. And I hope I've given you just a few ideas about how to do this analysis and not being intimidated by it all. And, I was going to get into all these technical details, and that's what I got in some big trouble for anyway. So maybe I'm just going to stop this video right this minute.